A Stuart Models beam engine rebuild. Part 17. Thinning the steel plates on top of the column. The question is, why do I need to thin the steel plates on top of the column? Well, because they are too thick. Next obvious question, well, why didn't I make the steel plates out of thinner sheet steel? The answer is quite logical and simple, really. If I'd have made the top plates from thinner sheet steel, then I wouldn't have been able to make a video about how to thin out thin pieces of steel to make them even thinner than they already are. And also it gives me a good opportunity to show you this tool that was sent to me by a very kind viewer called Dan. I'm using this tool as a face mill. It will take all of the metal off at the same time. But before I use the tool, I'm going to make sure that the carbide inserts are tightly clamped to it, because it wouldn't be good to spin it and then get bombarded with 3 very sharp carbide tool inserts. As it turned out, the tool inserts were very tightly clamped in place, so now I can spin the tool with confidence. It's always a good idea to check things like this. The next part of the job is to find some suitable packings that fit in the gap in the machine vise to hold the steel plates in the correct position so I can remove some of the metal from them. Before I receive lots of comments from viewers saying, "Why don't you use parallels? They would be much better and much flatter." Yes, indeed. But I haven't got any. And for possibly the millionth time, I make these videos for the benefits of beginners to the hobby. As I haven't got any parallels, which are just parallel pieces of metal, I'm assuming that neither do most beginners. That's why I'm using lathe tools. By using a combination of carbide tip lathe tools on this side, I can build up a makeshift support block to hold the pieces of metal so that I can clamp them in the machine vise one at a time to remove just the right amount of metal from the top. That's what's happening on screen at the moment. Because this tool is new, the carbide tips are very sharp and it's cutting beautifully. I should, I suppose, use coolant or at least oil, but for the purposes of the video so you can see what's happening, I didn't. I'm cutting this dry and it's cutting okay. And don't forget, I only ever use modest machine tools, well for the moment anyway. I may buy a better lathe, but that's another story. This is a very old machine. It's called a Naerok, spelled N-A-E-R-O-K, and if you reverse the letters, that spells Korean. So an intelligent guess by me says I think it was possibly made in Korea. I thought it would be a good idea, whilst machining so close to the machine vise top, to make the tool actually touch the top of the jaws on the machine vise and see if they're accurate. And they're not bad, but they're not perfect. What I will do, and I may make a future video about it, is clamp the jaws together and then using this tool take a cut across the top to clean up the machine vise and make sure that it's perfectly square to the cutting area of the tool. I've learnt from experience that when you make videos for YouTube, people comment on them, and sometimes the comments are really bizarre. And some of them are just incorrect. One of my Patreon supporters decided not to support me anymore, and as he terminated the support, he left a message. The videos have become too short for my liking lately. Which is odd because my videos have actually become longer in the last 12 months. I don't make them longer because most people don't even watch them full length according to the statistics on YouTube. And then they send me a question which is already answered in the video if they'd watched it to the end. Now the machining operation has finished, I'm cleaning off any tool marks on the tops of the pieces of metal. And doing this using your hand on a piece of sandpaper makes your fingers very sore after a while. So it's top tip time. This is a really good idea. I'm using a telescopic magnet. Being a magnet, it sticks to the piece of steel, and by holding it by the magnet, I can now rub the piece of steel up and down this piece of emery cloth for as long as I like without making my fingers sore. These days there are some really good magnets available. The best ones to use are the neodymium type. Once they're stuck to a piece of steel, they're quite hard to remove. Here's a shot of the first metal plate, suitably thinned, mounted on top of the column. Only loosely mounted, but mounted nevertheless. And here I'm bolting the second piece of metal in place. The next part of the job was to quickly spray the top part of the column. This is etching primer, as I would normally use on bare metal. And now try to contain your excitement as I stir the paint. This is Great Western Railway's green paint. And to be completely precise so I don't get lots of questions, this is pre-1945 GWR Railway paint. The good thing about this paint, apart from it being from a company called Phoenix Paints, and to give the tin of paint its full title, Phoenix Precision Paints. This is really good paint. You paint it on, not too thick and not too thin, and then once you leave it, all the brush marks disappear. It's beautiful stuff to use. And once the paint's dried and hardened, it's very durable. I've painted a lot of models over the years using this stuff, and it's really good. Often I've used green, but occasionally I'll use Crimson Lake. I've even had some of this paint put into aerosols by a company called Autopaint Northern, and that's going to be used for painting my 5-inch gauge Sterling single when I get round to it. Today some steam locomotives are arriving in the workshop, so there'll be quite a bit about steam locomotives coming up. But that's it for now, and here's the usual gratuitous shot of the paint drying. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.